Good morning, class. Today we're starting one of the most important and scoring chapters in physics, current electricity. This topic is very useful for objective exams like GE mains, emset, and other state-level entrance tests. Let's break it down topic-wise with concepts, formulas, objective questions, and homework. Topic 1. Electric current. Concept. Electric current is the rate of flow of charge in a conductor. It is represented by I equals to QIT, where I power current in amperes, Q or charge in coulombs, T or time in seconds. Formulas: 1 E Jan QT, 2 1 ampere au 1 coulomb 1 second, 3 direction of current Wechschuss from positive to negative terminal conventional current. Objective questions with solutions. 1. If 10 C of charge flows in 2 seconds, what is the current? A 2 B 5 A C 20 I D 10 A. Solution: I QT else 10 2 for 5 A. Answer B. Q. The unit of electric current is A volt. B ampere. C coulomb. D ohm. Solution: SI unit of current is ampere. Answer B. 3. If current in a wire is 3A, how much charge flows in 4 seconds? A 12C, B 7C, C A 33C, D 0.75 C. Solution: Q I X T mirror 3 X 4 art 12 C. Answer A. Homework question. A current of 0.5 flows for 10 minutes. Find the total charge transferred. Hint: convert time into seconds and use Q watt town IXT. Topic 2. Ohm's law. Concept. Ohm's law states that voltage is directly proportional to current when temperature is constant. VI. Formulas: 1 V psi R, 2 R der VI, 3 resistance R unit ohm O. Objective questions with solutions. Since if V is 12V and R is 4O, what is the current? A3A, B quare, C 12A, D6A. Solution: I VR 12 4 up 3A. Answer A. 2. If current is 2A and voltage is 10V, what is resistance? A pendo, B ecosia, C dodeco, D outfall. Solution: R and VI 10 2 the 5 O. Answer A. 3. Which of the following is correct according to Ohm's law? A. IR, B. Werner, C. VI, D. Viet I to R. Solution: VI. Answer C. Homework question. A bulb has resistance of 10 O. If 2A current flows, find the voltage across it. Hint: use V, Yo, IR. Topic 3. Resistivity and resistance. Concept. Resistance depends on material, length, and area. RX, L, A, where R high resistance. Art abendfad resistivity, material property. L, inner length of conductor. A dot cross-sectional area. Formulas: 1 R margin R, LA. 2 unit of resistivity, I and me. Objective questions with solutions. 1. If length is doubled and area is halved, resistance becomes A doubled, B quadrupled, C same, D halved. Solution: RLA, R becomes 4 times. Answer B. Q2. Which of the following has lowest resistivity? A copper, B glass, C rubber, D plastic. Solution: copper is a good conductor. Answer A. Q3. Resistance of a wire is 5 ohr. If its length is doubled and area unchanged, new resistance is A. Theopamental, B. Deca au, C. Kosua, D. Wenekespedor. Solution: RL, new R, 2x5 M10 O. Answer B. Homework question. A wire of length 1 mm and area 1 mm 2 has resistivity 1.7x 10.8 ohm. Find resistance. Hint: convert MM2 to M2 and apply RLA. Great! Let's continue our physics class on current electricity with the next important topic. Topic 4. Drift velocity. Concept. Drift velocity is the average velocity of electrons moving through a conductor under an electric field. Electrons move slowly and randomly, but when a voltage is applied, they drift in one direction. Formula V size I NAE, where V par drift velocity, ms I car current, a n r number of electrons per unit volume, a higher cross-sectional area, m2, e higher charge of electron, 1.6 x 1019 c. Objective questions with solutions. Q1. What happens to drift velocity if area A is doubled, keeping current constant? A halved B doubled C unchanged. D. Zero solution V1A. If A is doubled, V becomes half. Answer A Q2. Which quantity remains constant in drift velocity formula for a given material? A IBEC AdV. Solution E. Electron charge is constant. Answer B Q3. If current is 3A, A SARC 1, NM2, N Frux 8 x 1028 electrons M3, find drift velocity. A 2 and 34 x 10 4 MSB, 2 34 x 10 to 3 MSC, 1.2 x 10 5 MSD, 1.2 x 10 4 MS. Solution, use VI, nay, convert A R bar 1 MA 2 bar 1 x 10 6 mid to V 234 x 10 4 MNS. Answer, a homework question. A wire of area 2 min 2 carries a current of 5A. If N SAR 1029 electrons M3, find the drift velocity. Hint, convert M2 to M2 and use V SAR I, Ni. Topic 5, combination of resistors. Concept, resistors can be combined in two ways. 1. Series, same current flows, total resistance adds up. 2. Parallel, same voltage across all, total resistance decreases. Formulas for series R1 plus R2 plus R3 plus. For parallel, 1R, 1R1 plus 1R2 plus 1R3 plus. Objective questions with solutions. Q1. 3 resistors of 2R, 3R, and 5O are in series. What is total resistance? A 10R, B 50, C 30, D 2R. Solution. R2 plus 3 plus 5, hard 10R. Answer AQ2. 2 resistors, 6R and 3O are in parallel. Find the equivalent resistance. A 2R, B 3R, C 4R, D 1R. Solution. 1R, R16 plus 13, R12, R2R. Answer A3. In which combination is the current same in all resistors? A parallel, B series, C mixed, D none. Solution, current same in series. Answer B. Homework question. 3 resistors 4A, 6O, and 12R are connected in parallel. Find the equivalent resistance. Hint, use 1R, E, 1R1 plus 1R2 plus 1R3. Great. Let's move ahead with 2 more important topics from current electricity, Kirchhoff's laws, and Wheatstone bridge. These are very scoring topics in exams like G mains and emset. Topic 6, Kirchhoff's laws. Concept. There are 2 Kirchhoff's laws used to analyze complex circuits. 1. Kirchhoff's current law, KCL. The sum of currents entering a junction equals the sum of currents leaving the junction. Based on charge conservation. 2. Kirchhoff's voltage law, KVL. The sum of voltage drops in a closed loop is 0. Based on energy conservation. Formulas. For KVL, SV RART 0 in any closed loop. Take voltage gain as plus and drop as O. Objective questions with solutions. Once in a junction, 3A enters, 2A leaves. What is the other current? A 1 A leaving. Besne entering. C 5 A leaving. D 2A entering. Solution by KCL, 3A and DAR 2A out, plus X error 1A out. Answer A. Q. KVL is based on A. Law of inertia. B. Conservation of energy. C. Conservation of charge. D. Newton's second law. Solution, KVL, energy conservation. Answer B. Q3, in a closed loop, if there are 10V battery and resistors, drop 4V and 6V. Total voltage is V. C. D. Solution, total loop voltage. Faust gain, drops, Faust 10, 4 pole 6, Faust 0. Answer B. Homework question. At a junction, 5A current comes in, and 2A and 1A go out. Find the missing current and its direction. Hint, use KCL and assume I out 5 power 2 plus 1 plus.
Topic 7. Wheatstone bridge concept. A Wheatstone bridge is a network of 4 resistors used to measure unknown resistance accurately. It is balanced when the bridge gives 0 current through the galvanometer. Formula, balance condition. When the bridge is balanced, R1, R2, R3, R4, where R1, R2, R3 are known resistors. R4 is the unknown resistance objective questions with solutions. Q1. In a balanced Wheatstone bridge, which statement is true? A. Galvanometer shows maximum current. B. Galvanometer shows zero current. C. Battery disconnects. D. Voltage becomes zero. Solution. In balanced state, zero current in galvanometer. Answer B. Q2. If R1, 10 ohm, R2, 20 ohm, R3, 15 ohm, what should R4 be for balance? A. 20 ohm, B. 30 ohm, C. 25 ohm, D. 10 ohm solution, 10, 20, more 15 R4, R4, ohm, 30 ohm. Answer B. Q3. Wheatstone bridge is used to measure A. Power, B. Resistance, C. Voltage, D. Current. Solution. It is used to measure unknown resistance. Answer B. Homework. Question. In a Wheatstone bridge, R1 or 12 O, R2 or 6 O, and R3 or 10 R, find R4 for balance. Hint. Use R1, R2, R3, R4, and solve for R4. Awesome. Let's now complete the next two important and scoring topics for current electricity: meters, ammeter and voltmeter, and electrical energy and power. These are direct and frequently asked in JEE mains, emset, and other objective-based exams. Topic 8. Ammeter and voltmeter concept. 1. Ammeter measures current in a circuit, always connected in series. Should have very low resistance so it doesn't affect the current. 2. Voltmeter measures voltage, potential difference, always connected in parallel. Should have very high resistance so it doesn't draw current. Formulas. No new formulas, but understanding the connection and resistance of meters is important. Objective questions with solutions. Q1. An ammeter is always connected. A. Parallel to resistor. B. Series with resistor. C. With battery only. D. Across the switch. Solution. Ammeter is connected in series. Answer B. Q2. Why should a voltmeter have high resistance? A. To allow more current. B. To avoid heating. C. So it doesn't draw current. D. For accuracy. Solution. To avoid drawing current. Answer C. Q3. Voltmeter measures A. Current. B. Resistance. C. Charge. D. Voltage. Solution. Voltmeter measures voltage. Answer D. Homework. Question. Why is it dangerous to connect a voltmeter in series in a circuit? Hint. Think about what would happen if high resistance is placed in the path of current flow. Topic 9. Electrical energy and power. Concept. When current flows through a resistor, energy is consumed and power is dissipated. Energy is the total work done. Power is the rate at which energy is used. Formulas. 1. Power. P. She's Vx, she's I2R, she's V2, R2, energy, W, she's PT, she VIT, 3. 1 kilowatt, she's 1000 watt x 3600 seconds, she's 3.6 x 106 J, unit used in electricity bills. Objective questions with solutions. Q1. A 100W bulb works for 10 hours. Energy consumed is A. 1 kilowatt B, 10 kilowatt C, 0.1 kilowatt D, 1000 kilowatt. Solution. E 100 hours 10 or 1000, watt 1 kilowatt. Answer A. Q2. If current is 2, A. Resistance is 5 O, find power. A. 20 WB 10 WC 5 WD 25 W. Solution. P. I2R 22 X5 4 X5 there are 20 W. Answer A. Q3. Which of the following is not a unit of energy? A. kW. B. Joule. C. Watt. D. Calorie. Solution. What is unit of power, not energy? Answer C. Homework. Question. A heater of 2000 W runs for 2.5 hours. Find energy consumed in kW. Hint. E. Power X time in hours. Alright students, let's wrap it up. Climax of the lesson, current electricity. With this, we have successfully completed the entire chapter of current electricity, a powerhouse topic for JEE mains, emset, and all competitive exams. Each concept, formula, and MCQ you've tackled today brings you one step closer to your dream rank and future goals. Now remember, practice daily, revise smartly, and never lose confidence, because you're not just learning physics, you're mastering it like a future engineer. Class over for this chapter. Get ready for the next mission, magnetic effects of current, or any topic you choose next. Let's go conquer more.